For a moment, the world held its breath. Just 1 week ago, an object entered our solar system, silent, cold, and older than anything humanity has ever touched. Astronomers gave it a name, 3I/Atlas. But what they saw next didn't fit any textbook. It brightened too quickly. It moved in ways no ordinary comet should. And deep inside its glowing tail, telescopes detected chemical signatures that raised a question scientists rarely dare to ask. What if this isn't just a comet? What if this is something else? Some say it's simply an ancient fragment of ice, drifting between stars. Others whisper a far more unsettling possibility that 3I/Atlas might be a visitor, observing us as it passes through our cosmic neighborhood. But speculation alone is never enough. Tonight, we go beyond the rumors, past the noise and into the science. Because to understand what 3I/Atlas truly is, we must trace its journey from the moment it appeared to the moment humanity realized it may not be completely natural. The story began when the Atlas Survey telescope in Chile detected a faint, unfamiliar object moving against the stars. Early calculations revealed something extraordinary. Its orbit was hyperbolic, meaning it wasn't bound to the sun. It wasn't from here. It had entered our solar system from interstellar space. Almost instantly, observatories around the world began to track it. Some saw a diffuse coma, a cloud of dust and gas expanding around its nucleus. That suggested a comet. But as the days passed, 3I/Atlas didn't behave like one. It brightened far faster than models predicted. Its tail shifted shape in unexpected ways, and its chemical signature pointed to something rare, something we had never seen in a visiting object before. To some, these anomalies meant we were dealing with a comet unlike any other. To others, they were signs of intention, signs of engineering. And as the world watched the strange visitor grow brighter in the night sky, a single question emerged. What exactly had entered our solar system, and why now? On July 1st, 2025, the Atlas Survey telescope in Chile made a discovery that would capture global attention. The object's orbit was traced, and it didn't belong to our solar system. It came in on a hyperbolic trajectory, meaning it wasn't bound to the sun. It was interstellar. Astronomers estimated its closest approach to the sun, perihelion, would occur at about 1.4 astronomical units, not too far inside the orbit of Mars. Observatories around the world mobilized. Hubble, Webb, and ground-based telescopes all began to point at 3I/Atlas. Meanwhile, on social media and in forums, the speculation grew. Was this just a comet or something more? Early observations confirmed that 3I/Atlas was active, releasing dust, forming a coma. Polarimetric data taken by large telescopes revealed something unusual. The polarization of light reflected by the comet showed a deep and narrow negative polarization branch, far more extreme than most comets. This raised eyebrows. Some scientists suggested that the composition of its coma might be fundamentally different, indicating a type of object we had not studied before. Was it a pristine comet, or something altered by its interstellar journey? As 3I/Atlas drew closer, spectroscopic observations from the James Webb Space Telescope revealed an unexpectedly CO2-rich coma. The ratios of gases were not typical. Water was present, but CO2 seemed to dominate. This suggested that the nucleus of the object might contain ices very different from those seen in typical solar system comets. Some researchers interpreted this as evidence that 3I/Atlas came from a star system very different from our own, perhaps one where ice formation followed a distinct path. Others, more speculative, entertained the idea that such a composition might hint at something non-natural. Simultaneously, ultraviolet observations detected OH emission, a signature of water breakdown. The measured water production rate was surprisingly high, given the distances involved. According to these measurements, a substantial portion of the surface seemed active, potentially more than 20% by area. These findings bolstered the case for a genuine comet, but they also deepened the mystery. If there was that much activity and yet strange gas ratios, what was the true nature of 3I/Atlas? The comet's path was mapped in exquisite detail. Pre-discovery images were found dating back to mid-May 2025. As it moved inward, its dust production rate, measured by telescopes, followed a clear pattern. The size and velocity of the dust grains pointed toward large particles being ejected slowly, behavior somewhat consistent with other comets, yet showing subtle differences. The morphology also evolved. Early observations showed a sunward-facing dust fan. Later, a more traditional tail dominated. Meanwhile, polarimetric studies, measuring how light scatters off the coma, continued to intrigue scientists. The high negative polarization indicated that the surface material might be made of dark, icy grains, or even previously irradiated substances. Such features are rare, suggesting that 3I/Atlas could be fundamentally different from comets born in our solar system. Some researchers propose that the coma's unusual polarization results from interstellar radiation altering the object over billions of years, a cosmic aging process that could explain its unusual optical behavior. Enter the critics and the conspiracy theorists. Among them, a few voices raised a provocative question. Harvard astrophysicist Avi Loeb suggested that some emissions, including a plume of nickel, might not match typical cometary outgassing. This, he argued, could indicate something more exotic. Is 3I/Atlas possibly a fragment of a non-natural body, or even part of a probe? These ideas were amplified online. In forums, users pointed to weird tail structures, sunward jets, and sudden brightness changes. Some claimed the object accelerated non-gravitationally, meaning it didn't move exactly how a passive rock should. Astronomers, however, urged caution. Many explained that cometary behavior is notoriously complex, especially for interstellar visitors. The high CO2 content, the dust production, even the polarization could all stem from natural processes: space weathering, radiation, and sublimation. Radio telescopes detected emissions from 3I/Atlas, but not signs of alien technology. Live science. Instead, the signals correlated with hydroxyl radicals, a byproduct of water molecules breaking apart, a classic sign of comet outgassing. The James Webb observations in particular suggested that 3I/Atlas has been bombarded by galactic cosmic rays for eons. That radiation may have transformed its surface, creating an irradiated crust several meters deep. This crust could hide pristine material underneath, but it also complicates interpretations. What we see now may not reflect its original composition from its parent star system. Polarization, composition, morphology. Each piece of data paints a portrait of a comet that is extraordinary, but not necessarily artificial. Scientists emphasize that while the anomalies are worth examining, they don't yet demand an extraterrestrial explanation. Meanwhile, the public continue to watch. Influencers, late-night podcasts, and social media feeds all speculated. Could 3I/Atlas be more than a visitor? The mystery was going viral. One striking voice in the debate came from forums on Reddit. Amateur astronomers claimed that images taken as 3I/Atlas re-emerged from behind the sun showed a tail that didn't align with solar wind physics. Some said the structure looked too collimated, too sharp, unlike typical comet jets. Another user noted, rocks don't move on their own. The speculation gained momentum, fueling rumors of non-gravitational acceleration, mass loss, and even potential propulsion. But scientific observations pushed back. Telescopes around the world confirmed that the tail structure, though complex, could be explained without invoking alien engines. Some of the reported acceleration might result from asymmetric outgassing over large dust grains, producing subtle forces. Observers from the Virtual Telescope project announced that as 3I/Atlas emerged into morning twilight, its tail became more visible, aligning with predicted geometry. To add to the fear and fascination, some users claimed censorship. On online forums, they said their posts about alien probes vanished, fueling conspiracies of a cover-up. Others suspected that space agencies were intentionally withholding images or data. Whether true or not, the rumors added another layer to an already strange story. Returning to hard science, researchers also tested whether a spacecraft hypothesis held up under rigorous analysis. They examined whether the mass loss, tail structure, and gas emissions could match a vehicle powered by fuel or propulsion. They found that, to sustain the observed effects, the energy requirements would be far beyond what is plausible for any known probe. So far, the comet model remained the strongest explanation. Meanwhile, another scientific breakthrough, pre-perihelion photometry, showed that the dust production followed a power law consistent with comet behavior. The slow ejection of large dust grains could explain the delayed tail development. This supports the idea that 3I/Atlas is not exotic propellant-powered craft, but a dusty, volatile-rich body. Polarimetric observations continue to intrigue. The highly negative polarization at small phase angles is rare, but not unprecedented. Some researchers suggested that the surface could consist of dark, refractory dust mixed with ice, a composition that fits an old, battered comet. The interstellar origin adds complexity. Such comets may have evolved in environments vastly different from our own, leading to unfamiliar surface and coma properties. Spectral data from JWST, along with water observations, suggest that 3I/Atlas may originate from a region of its home star system with different ice chemistry, possibly near a CO2 ice line. The low water compared to CO2 could be due to inhibited sublimation or a heavily irradiated surface. These clues hint at a comet that evolved through billions of years of cosmic exposure. As the discussion rages on, some key players call for more observations. Telescopes like Hubble, Webb, and ground-based observatories continue tracking 3I/Atlas as it departs the inner solar system. At the same time, scientists are refining models, comparing this comet to other interstellar objects like 2I/Borisov, and debating whether we need to expand our understanding of comet classification. In the end, the story of 3I/Atlas may not deliver definitive proof of alien technology, but it does deliver something far more valuable, a challenge. A challenge to our assumptions. A call to push the boundaries of science. An invitation to wonder. Because whether 3I/Atlas is an ancient comet or a fragment of something far stranger, it reminds us the universe is more mysterious than we ever imagined. And in that mystery lies our greatest opportunity to learn, to explore, and to never stop asking, what else is out there? Before we end tonight's journey, remember this. Discoveries like 3I/Atlas remind us how small we are and how extraordinary our universe truly is. If you want to keep exploring with us, the mysteries, the science, the wonder, make sure you subscribe because our next journey begins soon. Until then, keep your eyes on the sky. Something out there is always watching back.